All right, so what we're going to take a look at right now is the domain of a rational function. Now, remember, when we're talking about domain, we're talking about the set of all x's on our graph. And so we did this a lot at the beginning of the year, and we did it with our parent functions. Now, if we take a look here at our function, this is our linear parent function. And so we know that as this function continues going to the left and to the right, it's never going to stop. And so in this function, the domain is going to be negative infinity to infinity. Now, same thing with our quadratics. Our quadratics are going to keep opening wider and wider and wider. So as we read it from the left to right, that's also going to go from negative infinity to infinity. And the last function family that we spent a lot of time looking at were polynomial functions. Now, linear and quadratic functions are polynomial functions. They're just more specific families. So the polynomial functions always had a domain of negative infinity to infinity as well. But what we're going to start taking a look at today is we're going to start taking a look at what we call a rational function. Now, just like rational equations had variables in the denominator, our rational functions are also going to have variables in the denominator. So if you guys take a look at this first example, this is the reciprocal function, which is the parent function for rational functions. Now, one thing that you guys will notice about the graph of this is you'll notice that these two curves are separated. That in order for me to draw this graph, I'm having to pick up my pencil. Now, that's because this graph is not continuous. I have to pick up my pencil. Now, the reason it's not continuous is because there's always going to be a value here that my graph is never going to touch. And the reason for that is because we have these 10 commandments of math. Now, the first of which is show your work, but the second of which is what's important here, is thou shalt not divide by 0. Well, if my x was 0, I'd be breaking that commandment. So I know in this function, my denominator cannot equal 0. So what's happening is I can have every x value except 0. So if I were going to look at that on a number line, I can't have 0, but I can have every other number. And so what that's telling me is that my domain of this function is negative infinity to 0 union 0 to infinity. So we have to be able to determine what values of x are going to give us 0 in the denominator. Well, this one was clear. X can't equal 0. But when we take a look at this example, I need to find out what we are going to call the excluded value is. Now, to find my excluded value, I'm going to need to set my denominator equal to 0 and solve. So if I have x plus 3 equals 0, I get x equals negative 3. Well, that means if I plug negative 3 back into this denominator, I get 0 in my denominator. I can't have that. So x cannot be negative 3. That's the excluded value. Our domain then, if I can have every number other than negative 3, would be all of these. So that would be negative infinity, well, not infinity, to negative 3 union negative 3 to infinity. So when we're looking for the domain of these rational functions, we set our denominator equal to 0. We find our excluded values. Now, sometimes when you guys are going through and doing this, in order for you to find these excluded values, one of the first things you're always going to want to do is to factor your denominators. Now, this is going to factor to x minus 2 times x minus 3. But if I take those and set them equal to 0, that means then that x minus 2 equals 0 and x minus 3 equals 0. So I get x equals 2 and x equals 3. Well, these are my excluded values. If I plug them in for x, I'm going to get 0 in the denominator. I cannot have that. So if I know x actually cannot be those two numbers, and I take a look at this on the number line, my domain, I can have every other value other than the two numbers that would give me 0 in the denominator. So my domain in interval notation here is negative infinity to 2, union, 2 to 3, union, 3 to infinity. So this is the domain of that function. I can have everything except 2 and 3, because when I plug 2 in, I get 0, 3 in, I get 0. We don't want that.